All right, so my article was about aquifer flow types. The name of the article is Assessment of Regional Flow Type and Groundwater Sensitivity to Pollution Using Hydrograph Analyses and Hydrochemical Data of the Salida and Blue Eye Karst Springs, Albania. So I'm kind of going to break down each section of that throughout the presentation. A few terms before we get started. The most important for this is karst. And karst is a landscape underlined by limestone which has been eroded by dissolution, producing ridges, towers, fissures, sinkholes, and other characteristic landforms. So here you can see all of this big plateau that's been eroded by this stream. And most of the times with limestone features in karstic areas, there are these big aquifers underground. And those aquifers, they're all over the place. So you see them in Iowa with the limestone that we're familiar with, and then in Florida as well. They're in a lot of regions of the US, and they're really important for Albania. They're all over the place, and two important ones are used near the capital and down here for hydroelectric power. So they recharge in two key ways. The first being allogenic recharge, and that's basically when water hits the land surface and doesn't get absorbed immediately. It flows into these streams, the channels that we saw earlier that cut into the ground, and it also has autogenic recharge. So that's when it does hit the surface and it kind of gets absorbed into the ground like a sponge. And it basically gets filtered out once that way. And as it's coming out of the ground, we have conduit flow, which is like the reverse of this one. So it comes out in big streams and collective channels. And diffuse flow, where it basically comes out little by little in a more sponge-like filtering kind of method. So the actual place where the study happened was in Albania, and they studied these two aquifers. So the Salida Spring is the major water supply for the capital city, Tirana, and the discharge is 510 liters per second. So it's a lot less than the 18,000 liters per second discharge of the other aquifer, which is used for power generation. And the way, using the last slide, it has an autogenic recharge, meaning it gets filtered once when the water hits the surface, and conduit flow, if we go back. The conduit flow is where it has these big channels in the ground that lead out of the subsurface, rather than the sponge where it gets filtered the second time. And the one that's used for hydroelectric power actually does have that second filtration with the diffuse flow. So here's a Google Earth picture of Albania, and here's Tirana, the capital. And basically the the Salida Spring is a lot more important for this study because it is so close to the capital, and it's right there actually. So it's next to this big karstic plateau called the Mali Plateau, and there's actually agriculture in Albania that impacts the aquifer. So water will hit this plateau, get absorbed into the ground, and then come out in channels at this spot right here. So they use that water in Tirana. The study was done to examine the different types of aquifers, to assess the contamination risks of the different types, and to use them to categorize the two most important ones in Albania. Researchers measured the flow rates coming out of the underground aquifers. They created mathematical recession curves of the flow rate out of each aquifer after heavy rain events. They found that conduit flow aquifers like the Salida Spring respond with a quick spike in flow rate and then quick decay after that flow rate after the heavy rain events. So there's pretty heavy response to the actual rain when it comes. They interpreted these results to mean that conduit flow aquifers like the Salida Spring are more susceptible to pollution in the recharge water because the underground flow is a lot faster and doesn't have that second, what's the word? Filtration, that's it. So even though both aquifers undergo diffuse recharge or autogenic recharge at the surface, the difference in the way the water exits the earth puts conduit discharge aquifers at higher risk to upstream contamination than diffuse discharge. So why should a normal person care about this? Here's a diagram illustrating autogenic recharge. Basically up here getting absorbed into the surface and sinking down into the aquifer. You can ignore this part. That would be the allogenic recharge. And conduit flow, which is, this is correct right here, showing the water kind of coming out in a big stream. And that's kind of the model that we see at the Salida Spring, as well as with all this farming on the top surface. So granted, any runoff from that farm is going to go directly into the water source. And granted, it'll be filtered once as it seeps into the top layer of the earth. But this study argues that that's not enough, that in conduit aquifers, the water doesn't get filtered the second time as it exits the earth. And that's a key factor on the level of contaminants that, the water in the spring finds. On a broader note, people are going to rely a lot more on aquifers in the future. As we learned in Cadillac Desert, water use is only going up, and we are looking into aquifers as resources to mine. That means that the quantity of water in the ground is shrinking, which makes chemicals seeping into them more potent by ratio. If one is contaminated, it's important to understand how that happened and what we can do to prevent it, and how long the pollution might reside in the aquifer before it cycles out.